Okay, good morning, good afternoon, and good evening to everyone. So, with me here, I'm going to do the last part of the mathematical induction. We have had two lessons so far. The first part, which was talking about proving, where we were proving summation expressions. The second part was proving inequality expressions, and the third part is now, which I'm going to talk about in this video, which is divisibility. So just as we said last time, we said that under mathematical induction there should be three parts, three types of questions. There should be three types of questions, as we said last time. There should be three types of questions, as we said last time. The first part we said was solving questions involving summation. This is the first video which we did last time, where we will be solving questions involving summation. The second part is solving questions involving inequality types. The inequality types. And the third part is divisibility types, where a certain expression is divisible by a certain number. So divisibility types. So these are the three parts of any mathematical induction question which should be asked. So these are the three types which you have to focus on. So in today's lesson, which is the last part of mathematical induction, I am going to focus on the third, where we're talking about the divisibility types. So we'll be looking at the divisibility types of questions. So we'll be looking at the divisibility types of questions. So number one, we'll look at the first example. The first example will be prove that 4 power n minus 1 is divisible. Let me try to delete this. Prove that 4 power n minus 1 is divisible by 3. We want to prove that 4n minus 1 is divisible by 3. So the first understanding which we have to understand here is that when something is divisible, obviously it can be expressed as a multiple of 3. So if I'm saying that if a function or a certain number is divisible by 3, we're talking about it can be expressed as a multiple of 3. Recall something here. I want us to recall that. So the recalling you're supposed to have is that, for example, if we say numbers divisible by 3, so if you look at numbers divisible by 3, what happens if you look at numbers divisible by 3? Obviously, I'm going to have 3 itself. I can have 6, I can have 9, I can have 12, I can have 15, and the count continues. All these numbers are divisible by 3. And if a number is divisible by 3, then what are we having? We can express that number in terms of we can be able to factor out a 3 from that number. So it means this 3 which I have here can be the same as 3 factored out multiplied by 1. This 6 which I have here can be the same as 3 factored out multiplied by 2. This 9 can be the same as 3 factored out multiplied by another 3. This 12 can be the same as 3 factored out multiplied by 4. And this 15 can be the same as 3 outside multiplied by 5. So it means that if a certain expression is divisible by 3, it can be written in the form 3 power m, where m is greater than or equal to 1. This is what we are saying. So anything which is divisible by 3 is in the form of 3 power m, where m is greater than or equal to 1. As you can see, when m is 1, the factor we have, the multiple we have is 3. When m is 2, the multiple we have is 6. When m is 3, the multiple we have is 9, and the count continues. So this is the first understanding which you have to have every time when you're solving a question of divisibility. The first thing you have to understand is that when you're solving a question of divisibility. So now, we continue. The question is, we are trying to prove. The question is, we are trying to prove that 4n power n minus 1 is divisible by 3. This is what we are trying to prove. So now, remember, this is by proof of what? By proof by mathematical induction. So the first thing you are supposed to write is, we shall prove by mathematical induction. We shall prove by mathematical induction. So proof by mathematical induction, we know there are two major steps. There is the base step and the inductive step. So number one, we look at the base step. So what do we do in the base step? Let n be equal to 1. We want to see if at all when n is equal to 1, the answer we're going to have will be a number which will be divisible by 1. So when let n equal to 1, what are we going to have? We will have 4 power 1 minus 1. And this is equals to 4 minus 1, which is equals to 3. And this 3, which is true, that which is divisible by 3. It is true that 3 is divisible by 3. 3 divided by 3, it will go there exact times. That's how much? 1 time. So it means the base step, it is true. That's the first step. So once you do that, which 3 is divisible by 2, it tells them that this is a true statement. This is what we want. Then from there we go to the inductive step. We know what the inductive step does. In the inductive step, what are we going to say? We are going to assume that n equal to k, and then for that n equal to k, it is also true for n equals to k plus 1. So here we can say assume this is n. How do you spell assume? Yeah, assume n equals to k exists. So assume n equals to k, then there exists a positive integer such that, now this time around the assumption is n equal to k. So if n is equal to k, we are going to assume there is a positive integer m. Actually, you can have m here. There is a positive integer m such that, remember the expression 4n 4 power n minus 1, but n is equals to k. So we are going to have such that 4 power k minus 1 should be equals to 3 multiplied by m. Just as we had an understanding that every n value insert there, we should have a multiple of 3 as our answer. So it means if n is equal to k, hapa ni n tuwaweka po k hapa. So it will be 4 power k minus 1. Since we do not know the value of k, we are assuming that this should bring out a situation where 3 should multiply by a positive integer m. This is what we are going to have. So we can let this to be our first equation. So let this to be equation 1. So if this is equation 1, then what is the second part? So if this is equation 1, what is the second part? So we are going to say that we need to show that it is also true for n equals to k plus 1. This is what the inductive step says. So when you assume that it is true for n equal to k, we also have to show that it is true for what? N equals to k plus 1. So for n equals to k plus 1, if we let n equals to k plus 1, what do we have? So obviously when showing for this, we will use this, will help us. Equation 1 will help us somewhere to make sure that for n equal to k plus 1, it is clearly shown. So we let n equals to k plus 1. It means the expression we're going to have will be 4 power k plus 1 minus 1. Now, let's now break this down. What is this going to be? We know that 4 power k plus 1, this just came with an understanding that for the fact that the powers here are adding up, how did that happen? It came up from a situation whereby we had the same base multiplying by different powers. So the indices property, where we had the 4 power k multiplied by 4, this is just the same as 4k plus 1. This is from the indices property, which you have to recall. So this is what we are going to use. So we'll break it down back to what we remember. So it means this can be written as 4 multiplied by k multiplied by 4 power 1. But remember, there is a minus what? There is a minus 1 this side. So what is happening there? So if we have that case, then we can now break it down to what we already know. So since this is 4k multiplied by 4 minus 1, so remember, recall back, we had let that 4k minus 1 is equals to 3 power n. This is what we said at first. So it means from here we can be able to have 4k to be equals to 3n minus what? So this will go to the other side, becomes plus 1 when we make 4k the subject. So if this is equation 2, meaning that from equation 1, where we have this, we've made 4k the subject, we are able to replace this in equation 2. Since we said in equation 2, 4k plus 1 minus 1 has been broken down to, this has been broken down to 4k multiplied by 4 minus 1. So after the 4k, what are we going to have? We are going to substitute with 3m plus 1. We are going to substitute with 3m plus 1. So it means in equation 2, where we had 4 what? K plus 1 minus 1. This now led us to 4 multiplied by k multiplied by 4 minus 1. This will now lead us to, apart from 4k, we put in 3m plus 1. We close, but remember it is multiplying by 4 outside. The answer, minus 1. After doing so, we can break the brackets. What are we going to have? 4 times 3, so we're going to have 4. We can have 4 multiplied by 3m. 4 times 1, we're going to have positive 4 minus 1. So that we'll have 4, I don't know why I'm writing 4 as 3. 4 multiplied by 3m here, but 4 minus 1 will give us a positive 3 there. So, what is happening? We can see a common factor there, which is a 3. So there is a 3 here, there is a 3 here, which can be factorized. So our instance here is, we don't have to be quick to multiply, but we can just try by all means to keep this, so that a 3 can still maintain its position. So that we want to remember, we want to show the concept where if it is a factor, the 3 or a multiplied by a something is clearly shown. So here we are going to factor out the 3. So if I factor out the 3 outside, what will I remain with? I will remain with this 4 and the m on the first. 3 is come out, will remain with plus 1 there. So what do we have? This implies that our 4k plus 1 minus 1 is equals to 3 multiplied by something. Hence, this is what? We can conclude that, hence, once the 3 is factored out here, it means the outcome here is a multiple of 3, because every multiple of 3 can be multiplied by what? The 3 can be factored outside. So with this shown for k plus 1, we can go ahead and conclude that, hence 4k plus 1 minus 1 is also divisible by what? By 3. Why are you concluding this? Because the 3 has been factored out, multiplied by a certain integer. This is an integer. So, if this is true, it's divisible by 3, hence the statement is what? Is true. Therefore, the statement four power n minus 1 is divisible by 3 for all natural numbers, or for all positive integers of n, and you are done. So just running through, what did we say? Just running through, what did we say? Number 1, we said that we have to understand that when something is divisible by 3, obviously the only thing which can be divisible by 3 are multiples. These are the multiples of 3 which we had here. So if these are the multiples of 3, these multiples can be expressed as 3 times m, where m is greater than or equal to 1. So 3 times 1, it is a 3. 3 times 2, it is a 6. 3 times 3, it is 9. 3 times 4, it is 12. 3 times 5, it is 15. That's what we said. And then from there, once this is clearly shown, 3 times something is clearly shown, it means that that item is clearly divisible by 3. So, when I want to prove this, that it is divisible by 3, we shall prove this by mathematical induction. And mathematical induction has 2 steps. The first step, we show the base rule, n equal to 1. So n equal to 1, the answer is equal to 3 here. So this 3 is truly divisible by 3, because it is in the form of what? 3 by 1. Then from there you go to assume that n equal to k. then there exists a positive integer m, such that if we substitute upper the n to be k, we are going to have 4k minus 1. So if this is divisible when n is equal to k, then the answer should be equal to 3 by m. This will become our first equation. So with this assumption, we will need to show that it is also true for n equal to k plus 1. So it means when I let n equal to k plus 1, after the n here, it will now be k plus 1 here as a power. So we'll now be trying to break this down in a simplified version where we'll have 4 power k multiplied by 4 from the rule of indices, since the powers we are adding here. So this is just as good as 4 power k multiplied by 4 minus 1. And in this equation, we'll just substitute after the 4 power k, we'll substitute from equation 1 what 4 power k is. Since 4 power k minus 1 is equal to 3, we can make 4 power k to be the subject. The minus 1 goes to the other side, becomes positive 1. Then you substitute inside there, multiply throughout, and simplify. After doing so, factor out your 3. Once the 3 has been factored out, you can conclude that the expression you have now is indeed a multiple of 3. Hence, this 4 power k plus 1 minus 1 is also divisible by 3. And if it is not divisible by 3, this makes us have the statement 4 power n minus 1 divisible by 3 to be a true statement for all natural numbers. And you are done. That's what we have there. So the second example I can use, I'm going to use the second example there. Let's look at the second example. Then we can have maybe an exercise later on. So we'll have question number 2 here, where I would want us to prove that 3 power 2n minus 1 is divisible by 8. This is the question. So since this time around we're talking about divisible by 8, anything divisible by 8, we know that it should be 8 multiplied by m. This is what you are supposed to understand. So that's the only idea you're supposed to go with. So let's start. First, tell them we shall prove by mathematical induction. We shall prove by mathematical induction. So if we are proving by mathematical induction, first thing is let n be equals to 1. So what are we going to have when n is equals to 1? We're going to have 3 multiplied by 2 minus 1. Power 2 multiplied by 1 minus 1 should be equals to what? This is just as good as 3 squared. 9 minus 1, this is equal to 8. And this answer, which is divisible by 8. So if this answer is divisible by 8, and you can go ahead and state that this is a true statement. This is a true statement. Next, the inductive step. So in the inductive step, what are we simply saying? Assume the statement is true for n equals to k. So if we assume that the statement is true for n equals to k, it means that the n to be couple k. So what are we going to have? We are going to have 3 power 2 k minus 1 will be equals to what? 8m, where m is a positive or is an integer. So every time when you introduce your m, define what your m is. Very important. Where m is an integer. So this is what we are going to have. So it means from this expression, we can even tell that this can be our equation 1. This is our equation 1. That's what we have there. So from this equation 1, what is going to happen? We can even make 3 power 2k the subject. So if we make 3 power 2k the subject, we're going to have 3 power 2k can be equals to 8m plus 1. You can call this to be your equation 2. So you can make this the equation, the subject in advance. So what are we going to do, number? We need to show that it is also true for n equals to k plus 1. This is what we want to show now. Once this is shown, you can go ahead and conclude that the statement above is indeed true. So showing that for n equals to k plus 1, it means we're going to have 3 power 2 open bracket k plus 1 minus a 1. Let's now simplify this expression. So this expression can be written as 3 power 2k. Okay, when we break the brackets, this will be plus 2 minus a 1. This, when the summation of powers are happening, this is the same as saying 3 power 2k multiplied by 3 power 2 minus 1. But remember 3 power 2k. Remember from equation 2. From equation 2, which we said there, we said that 3 power 2k is equal to 8m plus 1. This is what we said. So it means we can be able to replace that expression. We are now going to have 3 2k plus 1 minus 1, which is equals to 3 power 2k multiplied by 3 squared minus 1. After the 3 power 2k, we replace with 8m plus 1. This is multiplied by 3 squared minus 1 outside. Then from there, we can break the brackets so that we have 3 squared multiplied by 8m plus 3 squared minus 1. So that with this done, we are going to have 3 squared. This is as good as 3 squared is the same as 9. 9 multiplied by 8m. 3 squared, which is 9. 9 minus 1, this will be positive 8. This is what we have there. And once that is done, we are seeing number the 8 coming out. So 8 can be factored out, so that we can have 8 being factored outside. We will remain with 9m here, plus 8 has been factored out, will remain with a 1. So the idea is once 8 is factored out, 8 is multiplied by a certain integer, then this is true that for 3 power 2k, this is k plus 1 minus 1 is equals to 8 times a certain integer. So for this done, hence you can say that 3 power 2k plus 1 minus 1 is also divisible by 8, and hence the statement is true for P, or maybe you can just say for 3 2 power n minus 1 being divisible by 8, and you are done. So you can see that whatever is happening here is not that complicated. We're just using the same rules of mathematical induction, then and so forth. So I can look at the last question. So the last question I'm going to do, I'll look at the last question. So the last question says, this should be question number 3. So here we want to prove that n power 3 plus 2n is divisible by 3. So 3 divisible by 3 means 3 times m. That's what you have to understand. So what we do, we shall prove by mathematical induction. So proving by mathematical induction, what are we going to have? We can say let n be equals to 1. So if n is equals to 1, we're going to have we're going to have 1 power 3 plus 2 multiplied by 1. This is equals to what? 2 plus 1, which is equals to 3. And this 3 is divisible by what? Which is divisible by 3. Then you tell them this is a true statement. So this is a true statement. Next, the inductive step. So here, assuming the statement is true, for n equals to k, there exists a positive integer m such that what are we going to have? Such that when you replace upper n with k, we're going to have k power 3 plus 2 multiplied by k to be equals to 3 multiplied by m. Since we're talking about divisible by 3, so it is 3 times m, the positive integer. And this is going to be our equation 1. So if this is our equation 1, what are we going to have? So we need to show that it is also true for n equals to k plus 1. So how do we show that it is true for n equals to k plus 1? We are going to have k plus 1 power 3 plus 2 multiplied by k plus 1. Now let's break down and expand. So if we expand this, sure, you should be sharp in expanding. These are coming 3 times. K plus 1, k plus 1, k plus 1, that. Then you break the brackets by expanding throughout. Then what are we going to have? We're going to have k power 3 plus 3k squared plus 3k and then we'll have plus 1. So when you expand this, you have something of this nature. This is coming 3 times. And then plus 2k plus 1, we expand this again. We're going to have plus 2k plus 2. Then from there, we can try to simplify like terms, everything. We are going to have k power 3 plus 3k squared. This one and this one, that's 5k, plus 5k. This one and this one, that's 3, plus 3. This is what we have there. Then, what's next? From there, we can now break down something. Now, I want you to understand here that we are trying to use equation 1 to form that it is true for n equals to k plus 1. So from equation 1 there, we have something like k squared, k power 3 plus 2k. This is what we want to look for in whatsoever we've expanded. So that is why sometimes it is advisable, before you simplify, try to look for if you're able to see this thing. Once you see this thing, replace it immediately. So let's go back to our expression. We're looking for k power 3 plus 2k. So before you even write this statement here, before this is written, we can see something here. We are looking for k power 3 plus 2k. This is what we are looking for. So it means I can rewrite this as k power 3 plus 2k. This is what I'm looking for. The rest can go to the other side. So the rest will be plus 3k squared plus 3k. This is 1 plus 2, which is plus a 3. So we wanted this to clearly be seen because this is our equation 1. So from there, what is going to happen? We can have that. Remember that equation 1 was, we are looking at equation 1 so that we can manipulate the equation we are forming having a certain equation 1 in it. So the equation 1 was k power 3 plus 2k to be equals to 3m. So upper this will put in 3m. So that is why the expression becomes k plus 1 power 3 plus 2 k plus 1 becomes equals to, this is 3m. So this is 3m plus, adding this guys, 3k squared plus 3k plus 3. This is what we are adding to. So if we look at whatever is happening here, throughout we can see a 3 throughout, which means this can be factored, the 3 can be factored out. There is 3m here plus 3k squared there plus 3k there plus a 3, and that's our area of interest because we are talking about something divisible by 3. It means the factor 3 can be factored outside. So when we factor out the 3, this will be open bracket, will remain with an m there, plus will remain with a k squared there, plus will remain with a k there, plus will remain with a 1, will close. Once you've achieved in factorizing your 3, it means that you've achieved your goal. So hence k plus 1 power 3 plus 2k plus 1 is also divisible by 3, and hence the statement, which statement? The statement in the question, n power 3 plus 2n is divisible by 3. So hence the statement n power 3 plus 2n divisible by 3 is true, and you are done. So that's the statement which you are going to do. So this was the last example. So number, I can be able to give a certain task there based on whatever has happened. So the task you can do you can do the same, but just in short, you can do the same for questions to do with divisibility. The following questions are: I want you to prove that 6 power n minus 1 is divisible by 5. Number 2, I want you to prove that n squared plus n is divisible by 2. So those are the questions I can give out for your practice sake. Yeah, you can submit on our WhatsApp 0964 736805. Thank you very much and have a flavored day ahead of you. So this concludes our mathematical induction with the 3 steps or the 3 types: inequality, the summation which we did in part 1, the inequality which we did in part 2, and the divisibility which we've done in part 3 of this video. See you in our next lesson.